Good afternoon, everybody. Today we're going to finish up chapter 10 with section 10.7. We're going to look at circles in coordinate planes. Before we get into that, just please make sure you remember tomorrow is the chapter 7 review. And then when we come back on Monday, you guys have the chapter 7 test. So we only have one day of review tomorrow. So make sure you come with lots of questions tomorrow to go over. And then don't forget tomorrow, first thing in class, we're going to do the mini quiz over 10.5, 10.6, and then 10.7 should be on there too. Okay, so it's a mini quiz tomorrow, first thing in class. All right, so let's go ahead and get started with 10.7. Some of you might remember the equation of a circle, others might not, and that's okay. We're going to go over it here. A couple things that you have to remember from graphing lines. So we have y equals mx plus b, okay, slope-intercept form. You have the slope is m, the b is your y-intercept. So the thing that we don't 100% stress about would be the x and the y. You guys know that the x and y are just, they form the point or any point that lies on that line. Well, the same thing is true with the x and the y here in the equation of the circle. Okay, so that's why they're not in a different color. The most important things you have to pick out from the equation of a circle are h and k and then r. So h and k should, they should be in the same thing or represent the same thing, and then r being a different color is something completely different. So maybe off the bat, knowing it's a circle, you kind of know what h and k represent, and you know what r represents, which is great. We're going to discover that here. So when I pull this link up, I want you to pay attention to the equation of the circle that's on there, and what is the h and k doing to the circle, and what is the r doing, okay? So make sure you pay attention to that. We'll wait while this pulls up here. Okay, so if we look at this circle, right now the equation is x minus 3 quantity squared plus y minus 1 quantity squared is equal to 25. Okay, so your h is your 3, your k is your 1, and your radius is not 25, but if you look right here, it's 5. So 9 times out of 10, they're going to do this for you. They're going to actually square the radius and write it like that instead of writing 5 squared. So just make sure you pay attention to that. And if this number is, let's say it's 10, make sure you don't tell me that the radius is 10. Make sure you tell me that it's the square root of 10. Okay? All right, so now let's just see what happens when we change the radius, which hopefully we understand that it changes the size of the circle. Okay, so I'm going to go back to 5 actually, because those are nice numbers. Now look at the circle itself. We see that the center is at 3, 1, and we see B is a point on the circle at 6, 5. So look at this, look at the equation of the circle. Hopefully you see something that you should be. You should be seeing what h and k are. And h and k are the center of the circle. And I can move this anywhere around. Let's just move it down here. Pick a nice number here. Okay, so when it was up at 3, 1, you saw x minus 3, y minus 1. Well, now look what happens when I move this down. The equation becomes x minus 5 squared plus y plus 2 squared is equal to 25. Okay, so just remember, when you plug in numbers to the formula, the general formula is x minus y minus. So if I plug in a negative to that, I'm subtracting a negative, which becomes positive. Okay, so please pay attention to not only that, but also that they might not give you what the radius is. You might have to square root that answer to get what the radius is. Okay, now how many of you could look at this circle and tell me the radius very easily? Okay, hopefully you can see that it's just going to be 5 because we're looking from A to B. That's a vertical distance, and I can easily count from -2 up to 3, and that's a distance of 5. And then the same thing would be true if I moved it over on the y-axis. Now I'm looking horizontally, and I'm counting from 5 to 0, and that's a distance of 5 as well. Okay, but what would happen if I move this point over here? Well, essentially, I still understand that it's 5 because yes, I can cheat and I can count vertically and horizontally, but I want to make sure I understand why, okay? Because that's what we're about in geometry. We're looking at the why. Well, really, what are they just calculating in order to get these vertical or horizontal distances? Let me get back to that point. Okay, what are they calculating to get the distance between A and B if A is at 5, -2, and B is at 2, 2? Well, just form a triangle, and aren't they really just looking at the distance of the radius being the hypotenuse of that right triangle, to where my distance vertically is 4 and my distance horizontally is 3, and then I can just plug in 3 squared plus 4 squared to get that 5, because I'm really just taking 16 plus 9 and square rooting it, and that gives me that radius. That gives me the diagonal there, okay? So ultimately, it really always comes back down to the Pythagorean theorem. This is just the Pythagorean theorem written in a different way. We're talking about A being x minus 5 and B being y plus 2. So it's just something a little different. Okay, hopefully that makes some sense. Okay. All right, so again, standard equation of a circle, you got to know 2 pieces of information. You got to know the radius, and you got to know the coordinates of the center. Okay, so just remember H and K form your center, and your radius is R. And then X and Y in the equation, that's just any point that lies on the circle itself. Okay? All right, so let's do some work with these. So I'm going to give you problems like this, where it's straightforward. You have the center, you have the radius, so go ahead and plug it in. So let's write down the equation. X minus h quantity squared plus y minus k quantity squared is equal to r squared. Okay, so then from there, I literally just plug in. Here's my h and k. Here's my r. Plug it in and simplify. So you get x minus -4 quantity squared plus y minus 0 quantity squared is equal to 7.1 squared. All right, so since I'm subtracting a negative, this becomes x plus 4 quantity squared. And then with your y values, y minus 0, don't write that squared, write y squared. Okay? Because any 0 raised to any power is going to be 0, so just get rid of that. And then 7.1 squared is 50.41. So there's the equation of your circle. Okay, pretty straightforward. Just plug it in and simplify. Okay, now do the same thing, but just with the graph. Okay, so you're given the equation of the circle, so we're kind of working backwards. We're given the equation of the circle, and then you need to graph that. So all I need to do is identify, here's my h, here's my k. Now this is my r squared. So in order to get r, I have to square root that answer, okay? So my center lies at -2, 3, and my radius is 3. Now, remember that anytime you plug in a negative, that's when you're going to see a positive here in the equation. So please do not write 2, -3. Okay, you will be wrong every single time. All right, so now that I have those, I just go through and I plot them. So here's your center at -2, 3. And then my radius is 1, 2, 3 up, 1, 2, 3 over, 1, 2, 3 down, and 1, 2, 3 over. And then I'm going to try to make a circle that goes through those points, okay? And clearly they don't have to be perfect. All right, so hopefully that makes sense. And then let's look at this guy. So we have a circle whose center is at 5, -1, and the point 1, 2 lies on that circle. Okay, so we want the standard equation of our circle. All right, so first off, I'm going to identify that this is x and y, and then this is h and k. So what I really don't have yet is my radius. Yeah, I can look at the circle and I can kind of cheat, but I want to see the work to make sure that you know how to find this, because if this circle if it's not on a nice point like it is here, and let's say your radius is going to end up being like 5.2, you're not going to be able to see that, and you're not going to be able to count that in your coordinate plane. So you got to be able to calculate it. Okay, so yes, here we can see that I could count this way, and my radius is 5, or I can count this way and see that my radius is 5. But let's double check that with actually doing the math. So I'm going to plug it into the equation. So r squared is equal to, it's going to be x minus h, so 1 minus 5 squared plus y minus k, which is 2 minus negative 1 squared. So r squared is equal to negative 4 squared plus 3 squared. So r squared is equal to 16 plus 9. So sure enough, I end up getting the square root of 25, which is 5. So I just proved that it is 5. Okay, so now that I did all that, let's write the actual equation. So this is x minus h, which is 5 squared, plus y plus 1 squared is equal to 25. And remember, I don't want to write 5 squared, I want to write 25. Okay? All right. Hopefully that makes sense. Okay, now what we're going to do is we're going to do kind of like a proof, but we're not going to do a 2-column proof or anything like that. We're going to do some proof with math behind it. Okay, so what you need to do is you need to prove or disprove that this point, radical 2, lies on the circle that's centered at the origin. Okay, so the center is at the origin, and the point 2, 0 is on this circle. So my h and my k are 0, 0, and my x and my y end up being the 2, 0. Okay, so in order to prove that radical 2 is on, that lies on the circle, really the only thing that we're missing is r. So we've got to solve for that. Okay, so we have r squared is equal to x minus h squared plus y minus k squared. Well, if I want to get r by itself in this formula, I'm going to square root both sides. Okay, that gets rid of that. So now I have the square root of x minus h squared plus y minus k squared. And I hope some of you are saying, hey, why didn't the right-hand side, why didn't those squares go away? You have an addition sign. Order of operations, you cannot do that. It does not go away if you're adding those two squares. Okay? Okay, so now let's just go ahead and plug in our numbers. So r is equal to the square root of x is 2, and then minus h, which is 0, squared, and then plus your y, which is 0, minus your k, which is 0, squared. So now I end up getting the square root of, well, let's see, 2 minus 0, that's 2, so this is 2 squared, and then 0 minus 0 squared, that's just 0. So ultimately I have the square root of 4, which is 2. Okay, so now what you're looking at here is this. So basically what it's saying is a point lies on the circle if and only if the distance from that point to the origin is 2. Okay, so what you need to think about then is the distance from the point radical 2, radical 2 to the origin, which I'm going to write as 0, 0, is 2. Okay, well, we got to show that. Okay, so what I need to do is dot, dot, dot. I need to look at distance. Well, if you think back to the distance formula, we could do the Pythagorean theorem in its place. And what I said at the beginning of this video is, isn't the equation of the circle really the Pythagorean theorem? And you should be saying yes. And all that we're doing here in this slide is saying, well, instead of having r squared, let's just square root both sides and just get r by itself. So we're actually looking at the true distance formula here. Okay, so hopefully you're following me a little bit. Okay, so now what I need to show is that this distance between this point and the origin, it should be this radius, okay? So now I'm just going to plug in this x and this y with the same h and k. All right, so radical 2 minus 0 squared plus radical 2 minus 0 squared. So now that distance, okay, now just think to yourself, basically I have radical 2 squared plus radical 2 squared. This looks really messy because you have a radical within a radical, but that's okay. Because what's radical 2, I'll do a different color, this guy right here. What's radical 2 times radical 2? You should be saying to yourself that that's radical 4, which is 2. So ultimately what I have here is 2. And then I'll do this work over here. So this is radical 2 times radical 2, which is radical 4, which is 2. Okay? That's ultimately what we're saying here, simplifying what's under this entire radical. Okay, so then you end up getting the square root of 4, which is in fact 2. So what you just showed is that the point radical 2 lies on the circle that's centered at the origin, and it contains the point 2, 0. Okay, so ultimately, guys, what we just did is we solved for the radius of our main circle, our main circle being that you're looking at the origin and this point. And then we said, well, let's move, if you can picture that first picture I pulled up in Desmos, if you can picture that circle going from 2, 0, and then moving over to radical 2, all we just showed is that point, in fact, does lie on that circle. We didn't stretch the radius, we didn't shrink the radius. That's what we just showed. We showed that both of the radii with those 2 points are the same, okay? Make sure you jot down any questions you have with that, and we'll certainly go over that tomorrow if you have any, okay? All right, now, what we need to do here with this problem, we got to do a little thinking. Okay, so this says, which one do we have? So if we have this circle, this x minus 5 squared plus y plus 1 squared is equal to 4. Okay, there's our circle. Do we have a tangent, a secant containing a diameter, or none of those with the equation y equals x minus 4? Okay? And if you read that second question and you're seeing how would I solve this algebraically, hopefully you're not thinking, oh crap, I have no idea. Because you should see a system of equations in a sense. You have the first equation being a circle, you have the second being a line. So ultimately, we're looking at, okay, do I have a tangent line? Do I have a secant line? Or do I have a secant line that basically it is the diameter because it's hitting twice? That's what you have to prove. Okay, so again, some of us are thinking, holy crap, how do I prove that algebraically? Well, think of solving a system. We did this just last week or the week before. If I solve a system, all that I have to do is plug one of my equations into the other, or I need to eliminate one of my variables. Now here, the easiest way is going to be with substitution, with plugging that in, okay? Because elimination, I do not want to try that with 2 things being squared, okay? So algebraically, all you're going to do is plug in your y function or your y value anywhere you see it in the other one. Okay, so you're going to take that guy and you're going to plug it in, and then you're going to simplify. Okay, so let me pull up this new slide here, and we'll actually do the math here. And I went to the wrong slide. I gotta get rid of that ink, but all right, so we're gonna do all right, there we go. All right, we're gonna do the algebra here. All right, so we had the circle with this equation, x minus 5 squared plus y plus 1 squared is equal to 4. And then we had the line y equals x minus 4. So what I want to know is it a secant, a tangent, or a secant containing a diameter, or is it none of those? Okay, so we're going to use substitution. All right, so we're going to take this guy, and we're going to plug it in there. So I have x minus 5 quantity squared plus x minus 4 plus 1 quantity squared is equal to 4. So yeah, you got to do a little bit of algebra here. All right, so remember what it means to square a number. This becomes x minus 5 plus x minus, and I'm going to simplify this guy right here, x minus 3 squared is equal to 4. So then I end up getting x minus 5 plus x minus 3 is equal to 4. All right, so now when you see that, I hope you're thinking, oh crap, I have to FOIL, but I know how to FOIL, so it's not bad. All right, here we go. So x squared minus 5x plus 25 plus x squared minus 3x plus 9 is equal to 4. Now simplify all of that stuff. All right, we got 2x squareds. I'm going to cross those off. All right, then I'm going to combine this left side first. So I have minus 10x plus 25 and then minus 6x plus 9 is equal to 4. All right, so then I have 2x squared and then minus 10x minus 6, that's a minus 16x plus, and then you have 25 plus 9, which is 34, is equal to 4. That x squared should be a red flag. You should remember that when you have an x squared, you're going to end up needing to factor, so you need to get 2 sets of parentheses. So then you need to set this equation equal to 0. So 2x squared minus 16x plus 30, because you're going to subtract 4. And I'm going to come up here. Okay, factoring, I like my life to be easy. Okay, factoring is somewhat hard, so I want to try to do the easiest thing possible. So I'm going to get x squared by itself, which means I'm going to divide out that 2 first. So when I divide out 2 from everything, I end up getting x squared minus 8x plus 15 is equal to 0. Okay, so now I have to think, well, how do I factor? I get 2 sets of parentheses, x, operation. These 2 numbers have to multiply to equal positive 15, but add together to give me a negative 8. So I'm thinking 1 and 15. That's not going to work. 3 and 5. Ooh, that might. Let's try that. All right, so now a negative times a negative is a positive, and then a negative minus a negative is negative 8 here in this case. So we're good to go. We found our answers. Okay, so now what I have to do here is actually get what x equals. So x minus 3 equals 0, and x minus 5 equals 0. So x is equal to 3, and x is equal to 5. Okay? In Algebra 1, that's as far as you got. Okay? Now, here we're going to take it a little bit further, and I'm going to show you what this is exactly. And then Algebra 2, you're going to take this even further. So what you just found, in this case, these 2 points are solutions to your equation. So there are 2 solutions. Okay? So my answer to the question is, well, it could be a secant, or it could be a secant that it's basically incorporating the diameter. Okay? There should be an A in there. Not dim. Let's try that. Diameter. Okay. All right, so then you're good to go. Now let's actually look at what this is actually representing. So let me pull this little website up here. All right, so there's the circle. Okay, here's the circle that we have the equation for. Now if I type in your line here, y equals x minus 4, you see that in fact it is just a secant here. Okay, we knew that it was a secant because we got those two answers. Okay, we got the answer of 5 and 3, didn't we? So if you look at this equation, or at the circle and the line, the 5 and the 3, hopefully you see where those are actually, or what those actually represent. If you look closely here, that point is 5, 1. This point is 3, negative 1. Let's see if I can pin that. Okay, the 5 and the 3 just gave you the x values. Okay, so hopefully that makes a little bit of sense, finding out what you actually have, whether you have a tangent, a secant, or a secant that contains the diameter. So you're going to have a couple of those in your homework, and they're pretty straightforward. Now, the one thing you have to understand is the tangent, you have to understand vocab. Tangent only hits the line once. So if you get down algebraically to one answer, to one x value, you have a tangent because that line is hitting the circle one time only. And then if you get down to this part here, I'm going to do this in green right here. If you get down to that step and you cannot factor, please make sure you try the quadratic. Okay, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac, everything divided by 2a. If you plug your numbers in and you end up getting an error, or you get the discriminant, which, again, we're reviewing Algebra 1 here, if this discriminant ends up being a negative, that can't happen. So basically, if you cannot factor and the quadratic formula does not work, you get an error and you do not get an answer, then what you're saying is you have a circle and you have a line and they do not touch. Okay, so that would be neither. And then the secant, make sure you get the two solutions. Okay, so hopefully that makes a little bit of sense. We'll certainly go over those problems tomorrow if you have questions on that. But make sure you jot those questions down right now. Okay, so that's it for the notes. So this is your assignment. Please make sure if it asks you to graph, make sure I can read the graphs and there's nice scales. Make sure I see all of your work. And then the problems that I was talking about with the just this last slide, whether you have the secant, the tangent, those are 29 and 30. So please just make sure, just use substitution and use your algebra skills to solve those, okay? They should be pretty straightforward as long as you follow what we just did in the notes, okay? So we'll go over this assignment tomorrow and we'll get ready for the test on Monday. Have a good rest of your day and we'll see you tomorrow.